Ex nihilo means out of nothing, which implies that the observed universe can be derived from a state of nothing. It is then necessarily postulated that there is but one logically consistent universe. It is unique, and there can be no other. The tools with which and by which we are to construct the universe are those principles commonly observed in the real world. The assumption is that if we can take apart a wind-up clock, we can discern the why and the how of its mechanism by examining those parts. The logic of the universe is given to us all at once, as in a two-dimensional picture, but any explanation of that logic in words must come to the audience as a linear stream. The picture is then built up by assembling pieces, which only gradually integrate into a recognizable whole. So if you think I've forgotten some major piece of reasoning, I probably haven't. It will be along shortly. We begin with the state of nothing. What remains here with which we might begin construction of the known universe? We have the quality of the state, that is, the absence of anything. We give to it the symbol 0, meaning nothing. We have also a quantity of states, which is that there is only one state of nothing. We give to it the symbol 1. There are then two concepts inherent in a state of nothing, a quality and a quantity. This makes three concepts inherent in the state of nothing, 0, 1, and 2, but this in turn makes four concepts, and so on to infinity. Once we accept that nothing is composed of a quality and a quantity, we open the door to the entire set of integers. The concepts of 0 and 1 are logically congruent, like the front and back of a door. They cannot be separated one from the other, whereas the rest of the integers have a logical order to them. 4 is logically anterior to 5, and logically posterior to 3. We introduce here the primary postulates of existence. A postulate is a term taken as true without proof, because it is the means of proof. Thus one can prove nothing at all without a set of postulates to which all parties agree. These are, all that which interacts must have a form, and all that which has a form must interact. To exist is to interact. Existence might be defined minimally as consistency of interaction. If two things interact with one another in the same ways at all times without randomness, that is, consistently, we conclude that they exist relative to one another. That two objects exist relative to one another is logically proven, absolutely, only after infinite demonstration. Thus the universe validates its existence by demonstration, or the activities of matter prove or validate existence after the elapse of an infinite amount of time. Note here that form and interaction are logically congruent, just as quantity and quality are congruent. Thus a form is what another form perceives it to be. By perceiving, I mean the act of interaction. This is very important to what follows. There are three logical states to consider: anterior, posterior, and congruent. Congruent states govern much of the logic of existence that appears strange to us. The primary postulate requires that we embody an integer count in some fashion. The means given to us is geometry. The fundamental show put on by logic is a geometrical universe. In our three-dimensional continuum, the geometric pieces available are point, line, plane, and space. To embody an integer count, we need minimally a ray upon which the points representing the integers are laid out consecutively. A ray is a line that's been cut in half. It has a beginning but no end. Each point must be separate from its neighbors, else they would be the same point in the same place. The distance between points in 3 dimensions is called space. Space exists to logically separate individual units. Each point representing an integer has a logical place in the order of the count. To embody the counting process, some sort of marker must pass by each point in succession to embody the sum thus counted. For instance, the number 4 is embodied by a set of 4 points, but it cannot logically exist prior to the number 3, because 4 logically presupposes the numbers 1, 2, and 3 of which it is composed. The marker encompassing successive points is called the field of the set of integers. The embodiment of this anterior-posterior aspect of integers in physics is called time. One may rightly ask what the space between the integer points is composed of. It too is composed of points, but of a different type. That is, there are 2 sets of numbers, the integers denoting quantity, and the set of all numbers with an infinite number of digits, which denote quality. Note here that a line, infinite in both directions, is a circle of infinite radius. The set of integers is infinite, while the set of all qualitative numbers is, by Cantor's diagonal proof, infinitely larger still. That is, the integers cannot be put in a one-to-one correspondence with the qualitative numbers if we cut the circle apart and transform it into a pseudo-quantitative number by declaring a starting digit. A finite distance between 2 integer points is then filled by an infinite number of qualitative points, and this provides the logically necessary distinction between 2 countable units. One set is purely cardinal, the other ordinal numbers. An important distinction between these 2 types is that cardinal numbers can be displayed in 1 dimension, but ordinal numbers can only be properly displayed in 2 dimensions because ordinal numbers are laid out on a circle. The ray shows a quantity at each successive point, but the circle has no quantity specified. It is just an order of numbers. And this is why we live in 3 dimensions. 1 is for quantity, and 2 are for quality. So we must amend our original structure of a ray into a growing 3-dimensional space, wherein the present limit denotes the present extent of the set of counted numbers. In the real world of physics, this number is called the Baryon number, and is presently about 10 to the 78th power. Further, because no 2 points can be differentiated by their appearance, a field must grow from each point in 3 space. Thus each point is the origin of its own integer field, and the counts must also begin from each point simultaneously, else that point is differentiated from the others by temporal order. Now we must deal with the layout of individual countable points in space. The problem is this. Given a finite unit cube, what is the average number of points to be found within its confines? Of course, the question has no answer, because there can be no average number given that that number lies between 0 and infinity. The answer to this problem is the logical foundation of quantum mechanics. Observe this equation. Any finite number n is to the infinitely small as the infinitely large is to n. Thus, n squared equals 0 times infinity. Taking this as a true statement at this level of inquiry, we must then agree that all n are equal in the presence of the infinitely small or large. The logical quandary is made clear by demonstration. How is it possible that we might see something infinitely small, or infinitely distant? This makes no sense, for it then makes all finite quantities algebraically equal, which is again nonsense. The answer given by logic is to display elementary object as quanta, that is, all ones. Everything is 1 unit. There is no elementary object of 2.35692 units. There is only one, and it is identical to every other in the logical sense. Now, in the matter of the display in space, the answer is clear. Given an infinite space divided into unit cubes, into each cube is placed one countable unit. It is anywhere in the cube. That is, it possesses unit determinacy. It is in the cube. And unit indeterminacy. It is anywhere in the cube. Logic thus solves the quandary, yet has made no discernible asymmetric or unbalanced choice. It remains impartial. And this is a good place to introduce this postulate. By observation over the past few hundred years of inquiry into physics, it is found that nature makes no choice between logically equal alternatives. If constrained to make a choice one at a time, it will do one or the other in a statistically balanced manner, so that the sum of its choices is balanced. The advancing field emanating from every countable unit is a spherical reference frame. It cannot advance as a cube with corners, because this would introduce an asymmetry. The sum of all possible choices here is a sphere. So there are two types of fields present in existence. An infinite three-dimensional Euclidean manifold, which I call the alpha field, and a growing number of spherical fields I will call beta fields, for reasons to be made clear further on. As the beta field advances, it encompasses 4 pi r squared new countable units per unit time. Unit time is the time required for the advancing sphere to travel 1 unit distance, or roughly the surface of a sphere. The total number of integers encompassed will be 4/3 pi r cubed, the volume of a sphere out to the present extent of the advancing spherical surface. At present, each sphere has encompassed about 10 to the 78th power units, and adds about 10 to the 52nd units per unit time. The present radius of the universe is then about 10 to the 26th units. The rate at which the sphere advances is unit velocity, or in physics, c, which is the speed of light. By the rule of embodiment, when a new unit is encompassed by the expanding sphere of another, it must do something to embody the act of being counted. There are two fundamental possibilities. It may move in any direction, or it may disappear and reappear elsewhere. There are also two more possibilities in 3 space when we consider the extended field of each counted point. The field may rotate on an axis, or expand or contract like a balloon. This exhausts all conceivable possibilities in 3 space. Let us first consider movement. As a given countable unit is encompassed by the field of another unit, it will move in some direction to embody the fact of its having been counted. The total number of such movements will be 4 pi r squared times per unit time. So when the universe is 10 to the 26th units in diameter, which today is the Hubble radius, a countable unit or elementary particle will be encompassed by about 10 to the 52nd fields per unit time. Because the particle at the origin of every field is being encompassed by other fields at a prodigious rate, and may move in any random direction, its trajectory will be folded up about 10 to the 52nd times per unit time, yielding a net confinement, which I shall take to correspond to the Compton wavelength of the elementary particle. Our question then is, what is the reaction velocity of the central unit? That velocity, folded up 10 to the 52nd times per unit time, will yield a length. This rule produces an excellent fit to observation. Let the time required to traverse the field of a particle be equal to the time required for light to traverse the resultant confinement. This means that at reaction velocity, a particle would reach the Hubble radius in the same time that light would require to cross the confinement of the central particle. Here we note that the size of the universe to an elementary particle extends only to its Compton wavelength, because the particle knows only those effects immediately impinging upon it. For instance, if we deny spatial extension, we might say the universe is no larger than our eyeball, since we don't see the extension. We only see what is played out before us on the surface of a sphere of diminishing radius. At the particle level, making the transit time of light crossing the Compton wavelength equal to the transit time at reaction velocity across the entire extended universe makes logical sense and results in perfect concordance with observation. By adopting this rule, we find that objects at the Hubble radius will always appear to be moving away from us at light velocity, and other objects moving away at corresponding velocities proportional to their distance, just as is observed. Also, the central particle will have presently a Compton wavelength equal to that of a nucleon, just as observed, and these requirements will hold in perpetuity. We have then that the reaction velocity will be proportional to the square root of the Baryon number, which presently is about 10 to the 39th times greater than light velocity. The Compton wavelength will always be inversely proportional to the square root of the radius of the universe on this scale, and the observation of Dirac that the age of the universe divided by the time required to traverse the proton diameter at light speed always approximates the square root of the Baryon number, always holds true. By the primary postulates, the Euclidean alpha field and the spherical beta fields must do something to embody their existence relative to one another. Because each defines the nature of a straight line in 3 space differently, they composite to form a somewhat bent Euclidean frame and a somewhat straight spherical frame, and all beta field reference frames composite to determine the definition of a straight line at any point in composite space. That is, given a test mass in motion, its path will be determined by the composited frame. The universe thus makes no arbitrary choice, but rather simply responds to all those influences immediately upon any such test mass. The alpha field, now distorted by compositing with the beta fields, produces unit tension. That is, without any distortion, the alpha field has zero tension in the matter of a string fish net hanging limply from a fishing boat. By installing the beta fields, we supply fish that stretch the net. It now has unit tension and will transmit a signal through the net as a wave. That is, the tighter the string, the faster the signal will travel through it. And anything that reduces the tension conversely reduces the signal transmission velocity. We are now in a position to give the nature of inertia, mass, gravity, the nuclear force, dark matter, and dark energy in the simplest manner. When the origin of any beta field is encompassed, it moves in any direction. The direction of motion is affected by the definition of a straight line at that position. It is also affected by its own field, which is distorted by the motion of its center, because of the finite transmission velocity through that field. That is, when its center moves, the rest of the field lags behind, resulting in an ellipsoidal field, whose field lines tend to restore the center to its original position. Thus, when a particle moves in response to the appearance of new particles, it tends to be impeded by its own field, somewhat analogous to a lens resistance. This resistance acts only while the field is changing its position to complement its center, which is displaced. It resists acceleration by the central unit until that acceleration stops and the field catches up, once again becoming spherical, and is in uniform motion with its center. Inertia is then the interaction of a particle with its own field when that particle is accelerated. We can now see why matter clumps up. The fields of a particle's neighbors composite with its own field, and the direction of its random motion is skewed toward the largest clump. By accelerating toward the clump, its own field is distorted away from the clump, thus moderating the rate of fall. The composite of both distortions produces a flat Euclidean frame while under uniform acceleration, meaning that it will hold at that rate of acceleration. The beta field varies as 1 over r, and not as 1 over r squared, as given by elementary calculation. However, the resultant force varies as 1 over r squared, as observed. If m1 over r is multiplied by m2 over r, we get the familiar m1 times m2 over r squared, as given by Newton. But if the field varied inversely with the square of the distance, we could not algebraically separate such a mathematical entity from the empirically validated Newtonian equation. Clearly, matter is responding to the curvature of spherical fields and not to the exchange of gravitons from a field which varies inversely as the square of the distance from its center. The strength of gravity is proportional to the number of competing beta fields compositing with it, plus the alpha field, which retains a logical footing equal to the composite of all the presently counted beta fields. That is, the alpha field strength would be equal to 1 unit, while that of all the beta fields combined would equal 1 alpha field to composite the overall field at a given position. Numerically, since there are now 10 to the 78th beta fields, each beta field has a priority in establishing a reference frame of 1 to the negative 78th units. However, because the reaction velocity has increased from its initial c to 10 to the 39th times c, the strength of gravity should be on the order of 10 to the negative 39th, relative to the electromagnetic interaction, which we will show to reside in the alpha field, which retains a strength near its original unit strength. In addition to the gravitational interaction, there is an added interaction in the same direction as gravity, resulting from the compositing of the alpha field with the beta fields. I call this interaction the gravitational concomitant. When matter clumps, it reduces the tension of the alpha field in a manner similar to a few Cheerios floating in a bowl of milk. They go into clumps, driven by the surface tension of the milk in conjunction with a gravitational interaction. Thus, as the Cheerios clump, the level of the milk drops slightly, lowering it in the Earth's gravitational potential, while the overall milk surface area is lessened because it no longer need rise and fall from each individual Cheerio. The surface tension is thus reduced by clumping. In the same way, the initial unit tension of the alpha field is lessened, resulting in a decrease in the fine structure constant, which is the measure of the tension in the alpha field, which gives rise to the speed of light. Hence, as matter clumps up, the overall speed of light decreases. We have now the cause of dark matter and dark energy. The extra push given to matter in the same direction of any gravitational well is revealed as a compression on the scale of galaxies. Clumps of galaxies have higher velocities than would be explained by gravity alone, because an extra force is compressing the galaxies from without, giving them extra energy adiabatically, and holding them in the composite bag of gravitational well and the concomitant alpha field tension pressure. Scaled down somewhat, the stars on the edges of rotating galaxies are compressed and speed up by angular momentum conservation, while those near the center receive less compression due to the cancellation of the tension force vectors there. Dark energy is a simpler measurement effect due to the slowing of light velocity from unit velocity to 1/137th of the speed of light over the course of the age of the universe. Thus, if we hold light velocity as a constant, we are forced to conclude, from experimental data, that the Hubble constant is increasing and our universe is gradually becoming depopulated of galaxies, or we hold the Hubble constant as a true constant and let the speed of light decrease. Both approaches work to explain the discrepancies associated with type 1a supernovae. If it is true that the speed of light is decreasing due to the clumping of matter, then we can say with confidence that the universe cannot, in principle, become completely depopulated, because it is the clumping that drives the apparently accelerating universe. If the clumping of matter ceases by way of depopulation, the apparent acceleration must also cease, and we are back to a uniform Hubble expansion, in which case those objects that disappeared beyond the Hubble radius will reappear in a larger universe, and observers who hold that the speed of light is constant will aver that the expansion of the universe is then slowing. The random movement of a particle in response to the appearance of new particles at the Hubble radius yields the gravitational force through the lateral component of that movement relative to a distortion caused by the clumping of matter into galaxies, stars, and planets. The vertical component of those motions comes into play only at distances on the order of a few Fermis. One Fermi is about the Compton wavelength of the proton. The distance a central unit moves in response to the appearance of a new particle into its field is about its Compton wavelength. It is then redirected by the appearance of yet another particle into its field. These movements are folded up into its Compton wavelength. The particle does not random walk away from its position because it is affected by its own field. That is, its confinement is held against the random walk by inertia. When a particle approaches close to another, the lateral component of its reaction velocity disappears as shown, leaving only the vertical component. We have then that a given particle may move either toward or away from the proximate particle. The probability of doing so is weighted as n plus 1 over n for movement away, and n over n minus 1 for moving toward, where n is the distance of the particle. Adopting this rule yields the liquid drop model of the nucleus. At 1 Fermi, the force of attraction between two nucleons is maximized, while at 1/2 Fermi the force becomes repulsive, because any movement of 1 Fermi in length will take the subject nucleon away from its proximate nucleon. At distances of many Fermis, the probability of attraction falls off rapidly to neutrality, and these are the observed properties of the nuclear force. This also gives reason for the absence of any singularity in a black hole. The gravitational interaction disappears entirely at around a Fermi and yields to its partner the nuclear force. The attraction of one nucleon to another at close range depends on which field is dominant. The alpha field is dominant at large distances, such that any movement toward or away from another particle is substantially equal in length as measured in the beta field. However, the beta field, which I identify as the gravitational field, diminishes in value inversely with distance, so that when the beta field dominates, movement toward another particle is favored because the units of length, as measured in the beta field, become shorter as we approach the center of the beta field. Displacement toward another particle by 1 unit length in the alpha field may be many unit lengths in the beta field, while displacement away will be correspondingly less. Thus, the movement of a nucleon, when in proximity to another, favors movement toward the other nucleon. This proximate attraction geometrically objectifies the nuclear force. The electromagnetic interaction is a creature of the alpha field. This is the Euclidean reference frame which regulates the placement of beta field origins, the integer count, in 3-space. This field may be bent or twisted in response to the activities of the particles it contains, but cannot, of itself and as a whole, move about, rotate, or expand and contract. Consequently, it may only expand in one volume if a corresponding volume contracts. These are the positive and negative electrical charges. A twist in the field must similarly be accompanied by a counter-twist that restores the balance. Clearly, if an expansion of the field occurred without a corresponding contraction, the identity of the alpha field would be logically compromised. And by the quantum principle, all the charges must be identical. They are unit charges. A positive charge is attracted by the negative charge in the same way that the elliptical field of a beta field under acceleration is restored to its spherical rest state. The rear low-density volume fills the front high-density part. They cancel. An elliptical field has two foci. The front focus may be termed the primary particle, and the rear focus the secondary particle. Charges form around an initially neutral central particle when it is accelerated. The front of the accelerated beta field is compressed, so the alpha field must do something to validate that change. It expands or contracts over the front-end primary focus of the beta field and does the opposite over the rear-end secondary focus of the acceleration. If the acceleration is forceful enough and sufficiently long-lasting, the weak interaction may cause the two foci to separate by a random walk method associated with the uncertainty of position of each focus. That is, they can be in indeterminate places governed by Planck's constant. Planck's constant is the measure of logical slop necessarily present in the universe. This allows interactions to occur. Slop, in the engineering sense, is the tolerance of mechanical parts that allows them to move in a mechanical action. Without some element of slop, a machine seizes up. With too much, it falls apart or fails to perform the required action. We can then understand here that logic of itself cannot produce any kind of movement, because any logical proposition generates a perfectly equal and opposite proposition that cancels it out. Some element of absolute randomness is required to allow relative motion of the contents of the universe. If that randomness is excessive, we cannot reliably say that a given form exists relative to another form, because their interactions may be logically inconsistent. We must conclude, then, that the observable universe is the partial union of two sets, logic and chaos. Hence, in its initial state, each particle has both in equal portions unit determinacy alloyed with unit indeterminacy, and from empirical observation, indeterminacy is becoming an ever smaller attribute of the whole. That is, the universe is becoming more deterministic as time goes forward. What a given particle may do is mediated by the requirement that Planck's constant be conserved at all times under all circumstances. Its components are length multiplied by mass, multiplied by velocity, or, initially, the measure of the alpha field, unit length, multiplied by the measure of the beta field, unit mass, multiplied by the speed of light, unit velocity. The dimensions of Planck's constant are also momentum multiplied by length, energy multiplied by time, and units of angular momentum. We can vary one parameter by compensating with another to to preserve the constancy. By these means, action can occur, and the universe moves while preserving a measure of logical consistency. At the beginning of the universe, Planck's constant is 1 unit, which thereafter decreases as determinism displaces randomness. In the system of units used herein, Planck's constant is inversely proportional to the radius of the universe and is presently about 10 to the negative 26th. In the MKS system, it is the mass of the proton multiplied by the Compton wavelength of the proton multiplied by the speed of light. We are now in a position to calculate, at least to a good approximation, the values of the electron-proton mass ratio and the fine structure constant by examining the fundamental relationship between the two in the ground state of the hydrogen atom. Here we must answer the question of how much mass energy is required to produce a bare charge. That is, how is energy apportioned between the alpha fields and beta fields? If we consider the electron as a bare charge, it has a mass of 1/1836 part of the proton. Why? Note here that quantum mechanics has relegated the Bohr atom to the dustbin of physical theory, but its true application is as the orbit of the electron's locus of activity. By this I mean that although the electron's position is subject to fluctuations governed by Planck's constant, its locus is fixed and is as absolute as the law of conservation of linear momentum. For if that locus can detectably random walk away from its position, it would constitute a violation of the known laws of physics. The electron exists in an atom at some energy level as a statistical entity, but its locus follows a classically deterministic orbit that can be useful in resolving logical questions. The fine structure constant is then the orbital velocity of the electron's locus in the hydrogen ground state. We obtain this velocity by making use of the equality of the centripetal force and electrostatic force in the hydrogen ground state and the Bohr radius. This results, after algebraic manipulation, in a velocity of 1/137th of light speed for the electron in the first Bohr orbit. Now we take the Bohr radius and put it into the centripetal force equation and get that the binding force between them is proportional to the cube of the fine structure constant multiplied by the square of the electron-proton mass ratio. We have now a straight-up mathematical relationship that can be solved outside of physical theory as a probability function, because alpha and beta are pure numbers. That is, we can discard our dimensions of mass, length, and time with total impunity. Thus, given any number f, which is equal to alpha cubed multiplied by beta squared, what are the most probable values of alpha and beta? If this can be viewed as a probability function, we have the answer already. We want to know why these numbers are chosen rather than any others. If logic were solving this abstract problem, where the exponents of a and b were equal, then it would simply assign the square root of f to each parameter. It would have no reason to give more of f to a or to b. Giving the square root of f to each parameter, we get values of 1/1716 for beta and 1/143 for alpha. Not too bad. It's about a 5% error outside of the known values. But the exponents in this equation are not equal. One of them is 3 and the other is 2. Hence we might expect logic to give alpha more of f than beta. Given that q is the coefficient given to alpha by logic to increase its portion of f, we must then multiply beta by a factor of 1/q to balance the equation. We then have for all alpha and beta with equal exponents, q divided by 1 over q must equal 1. That is, q squared equals 1 for all equations wherein the exponents are equal. For those interested, that the exponential ratio is a mathematically meaningful quantity is given by this limit equation. Now we can set up a simple three-way equation where q cubed equals 3 over 2, and therefore q equals 3 2s to the 1/3 power, and also 1 over q is then the inverse 2/3 to the 1/3. When we apply it to the original problem, we get accuracies of 1 part in around 20,000. With corrections for the Rydberg energy, electron G factors, and perhaps a few others unknown to me, this should do it. The fine structure constant then decreases roughly as the 12th root of the radius of the universe, while the electron-proton mass ratio as the 8th root of the radius. The disparity between the size of the baryon number and other cosmological pure number constants are no longer problematic, because they scale from the inverse square root of the radius of the universe, of which the other constants are powers of. The alpha field maintains the length standard of space, while the beta field's rotation is the clock by which time is kept. The alpha field cannot itself, in principle, rotate. It can establish an axis of rotation because it is an infinite Euclidean reference frame. It is the fixed stage upon which existence is played out. However, the beta fields, which are the dramatis personae, may rotate in response to the act of being encompassed by the field of another countable unit. If we suppose that they rotate on any axis 10 to the 52nd times per unit time in the manner of the random movements which produce gravity, we have a complete cancellation of any effects that might accrue. That is, with so many random axes, we can't expect to detect any rotation in any particle. However, if we require that the axis of rotation be tied to the random movement by having the axis of rotation parallel to that movement, we can discern something like the observable magnetic field, as well as angular momentum principles, provided that we also assign a handedness to that rotation. When the beta field rotates, the alpha field must do something corresponding to that operation in order to validate its existence relative to the beta field. Thus, whatever the beta fields do, the alpha field must do something in tandem, else it does not exist relative to the beta field for that action. For the alpha field to do nothing is not logically permissible if we are to maintain a viable definition of existence. The corresponding mechanism in the alpha field in response to the beta field's rotation is to twist or deform. That twist will also have a designated handedness. Now, even though we have constrained the particle's rotation to a specific handedness, we still can't detect it if that particle is not in motion relative to us. The rotations will still cancel out. However, if it moves laterally relative to an observer, that observer will detect a net rotation because the sum of all the rotations leaves a remainder of rotations corresponding to its lateral displacement relative to the observer. And this displacement effect has a relativistic interpretation. Translational movement of a particle through the alpha field will result in a contraction of the beta field in the direction of motion. The reaction velocity, v, is given by this equation, where n is the number of other fields encountered per unit time, r is the radius of the universe, and d is the Compton wavelength of the proton. If n were altered by a factor z, the resultant confinement, d, would be altered inversely by a factor of the square root of z. Such a change would also occur when n is reapportioned by factors of 1 plus u, 1 minus u, and 1, where u is any velocity less than unit velocity. That is, the particle encounters 1 plus u more fields from the front per unit time, and 1 minus u from the back, while the sides remain constant, similar to driving into raindrops. Then 1 over z is proportional to the Compton wavelength, and z is proportional to the mass of the particle. The total number of fields encountered per unit time must remain constant at 4 pi r squared for all velocities less than c. Therefore, only the reaction velocity in the direction of motion is affected, which in turn determines the Compton wavelength. Here is the standard coefficient of relativistic contraction. So we have a contraction of the beta field in the direction of motion, which we can interpret as increased mass energy, and as a magnetic field if the beta field has a charge associated with it. I give to the neutron the status of fundamental particle. The initial beta fields are neutrons. The fact that it decays into a proton, electron, and antineutrino does not matter, nor the fact that physicists have it as one U quark and two Ds. The neutron is the nexus of two cones similar to those from which the conic sections are derived. As a tree is divided into a root system and a system of branches above ground, we divide logic itself into two zones so that the hierarchy of logic, from which we get the idea of reductionism, has no specific endpoint. That is, there is no top of the mountain. Rather, we define the top as the most used path. The neutron is in the trunk of the tree of logic, along with the alpha field. Quarks and other things are in the branches of the tree, and everything we deduce down from the alpha and beta fields is in the root system, or vice versa. The neutron decays by the weak interaction, which in turn is due to its uncertainty of position in combination with random accelerations. As the neutron moves by its reaction velocity, its surrounding field becomes ellipsoidal, because the displacement of its center, which is the particle, cannot be transmitted to the extremities of the field instantaneously. An ellipse has two foci, either one of which might be construed as a particle. At one focus a charge forms in the alpha field, and at the other focus an opposite charge. This conserves the density of the alpha field within the constraints of Planck's constant. The neutron then has local areas of charge, constantly coming into and out of existence. If such a charged focus manages to break free of the neutron's inertial cage by way of its uncertainty of position, the neutron will break into two particles, one positively charged and the other negatively charged. A problem then arises concerning the handedness of the neutron's rotation. The daughter particles have opposite translational movements. That is, they move away from each other. We'll call this opposed movement the T function. They have opposite charges, which we will call the C function. The problem is that the daughter particles both rotate with the same handedness, which we call the P function. Initially, they are rotating in opposite directions, as would be seen by an observer placed between them. However, that rotation has the same handedness in both particles when seen in combination with the particle's direction of motion. To conserve P, they must rotate in the opposite direction when the direction of motion is assessed, so that one particle has CPT plus and the other has CPT minus. This requires that the handedness of one of the daughter particles be flipped to the opposite sense. When this is done, P is still not conserved because it is now zeroed out by the oppositely handed daughter particles. This subsequent problem is solved by the production of the antineutrino, which carries away the initial handedness of the neutron. If we say that the initial neutron was right-handed, we now have two rights and one left-handed particle, thus conserving the initial right-handed p state. The handedness of the neutron differs from the handedness of the proton and electron. The neutron is what I call an N form, while the electron and proton are L forms. These are members of the set of forms that may pass through left-right and up-down inversions in a camera obscura. The waveform associated with a particle is linearly localized and behaves something like a wave passing through a small hole, expanding on the other side, but collapsing again to pass through another hole. This is analogous to the picket fence model for the polarization of plane localized waveforms or photons. There are 4 possible geometric forms in this set, plus a 5th if we define a dimension in addition to the travel direction. These are E, X, L, and N. If we define that extra dimension, we also get a T form, which is the same thing as the E form without the extra dimension defined. Thus, when the waveform passes through a camera obscura, an X remains unchanged and has no handedness. The N form remains unchanged, but has a handedness. The E form rotates through 180 degrees, while the L form rotates 180 degrees and displays a handedness as well. When a neutron rotates in conjunction with the reaction velocity, the 2 foci of the resulting ellipsoid move apart to embody the acceleration of the particle's beta field. Both foci rotate, generating the same helicity as they move away from each other. One forms a coincidental positive charge in one direction of motion, and the other the opposite charge. Relative to one another, they have the opposite rotation, but because they are moving away from one another, they generate the same helix, consistent with the handedness of the neutron. When 2 opposite charges rotate oppositely, they form a magnetic field in the same direction. That is, both magnetic fields reinforce one another rather than cancel. The neutron thus possesses no net charge, but generates a magnetic field by way of its intrinsic angular momentum. However, when the neutron moves laterally relative to another charge or magnetic field, the detectable fields cancel, and so cannot be influenced by external charged bodies and magnetic fields. The cloud of virtual pions surrounding the neutron, which are defined in the Standard Model as the mediators of the strong nuclear force, consist of the charges constantly being separated as the neutron reacts to the appearance of new particles at the present rate of 10 to the 52nd per unit time. At the beginning of the universe, the 2 daughter particles generated by the neutron are of equal mass but with opposite c, t, and p values. They are in effect antiparticles. However, the one that becomes the electron is going to lose mass relative to the proton as the universe ages. This identifies it as a lepton rather than an antiproton, and the proton retains the status of baryon. So, that aspect is conserved as well, and the integer count is not compromised. Conservation of baryon number must be the primary conservation law, because that is the purpose of existence in the first place, to embody the integer count. Time reversal symmetry, the T function, is an objective symmetry in that the concepts of forward and backward in time are quantitatively different. The integer count increasing is the logical foundation of the concept of time. We can tell the difference in sets of quantities of objects by comparing them to other sets of different objects. we can do non-symmetric comparative analysis. Thus we can say, if A is greater than B and B is greater than C, then A is greater than C. Similarly, we can add to this operation other sets, D, E, and F, and so on, and put them in a logical order, one compared to any other, as on a number line. Time reversal symmetry is then only symmetric at short intervals of time, during which the integer count cannot be definitively increased or decreased. That is, at times on the order governed by Planck's constant, time reversal symmetry must hold, there being no way to confirm any difference between past, present, and future at this scale. Charge conjugation, the C function, and parity, the P function, are subjective operations because they involve only qualitative attributes that can be defined only by comparison to their opposite. Thus we know that an object is left by comparison to right, and we know that the expansive charge, defined here as negative, is opposite to the positive, contractive charge only by comparing the effect each has on the other. But we do not know which is left or right, and positive or negative of itself. We can only know them by the relationship of left to right and positive to negative, taken together simultaneously. Because these attributes are subjective, and the perception of being is logically congruent with being itself, we have what may be called a simultaneous two-state. That is, what you may call left may be perceived by another as right, which is to say, the universe exists simultaneously in left and right-handed states, one of which will be perceived by the observer, and the other by yet another observer. No contradiction results, provided that each observer sees the entire universe from only one qualitative state. The universe then exists in the 8 operationally equivalent qualitative states given here. Every particle sees the universe and itself in one of these 8 states. Every experimenter sees the universe in one of these 8 states. Therefore, inquiring as to why there is no antimatter found in our universe is meaningless, because whichever state you designate as antimatter is one of the 8 states, and your neighbors are viewing one of the other states, all calling it by the same name, all without contradiction. The answer to the antimatter question is then, it is not missing, you are looking at it. The next question then is, why isn't a random selection of these states presented to each viewer? Because interaction is logically congruent with being, a thing is what another thing perceives it to be. Random perception on one end is equivalent to random being on the other. If a particle can be randomly any one of the 8 states, other particles can also simultaneously perceive them randomly, and random perception leads to quantifiable contradictions. That is, if we allow random perception, we might have one particle seeing, or interacting with, 4 other particles that it perceives as left, right, right, and right, whereas another particle might perceive the same 4 as left, left, right, and right. And one left with 3 rights is quantifiably different from 2 lefts with 2 rights. This is a clear contradiction both physically and mathematically, and cannot be allowed in any rational universe. Hence, all particles of the same type must be perceived by other particles as logically identical to one another, unless there is a causal element introduced to change one into another, so that we have antimatter particles appearing in experiments, but only because their being is causal and not random to all interactees. We then have our tree of logic divided into 2 different areas. The one dealing with quantum physics is primarily subjective, and describes what nature does in order to prevent logical contradictions. It consists primarily of delimiting what is prohibited. The other half is objective and produces the display of what is compulsory in order to geometrically embody the integer count. There are three types of logic associated with existence. These may be termed one-dimensional logic, two-dimensional logic, and three-dimensional logic. Because logic is fundamentally comparative, the three forms given are differentiated by their referent structure. That is, given an object or state, to what do we compare it to as a standard? One logic is self-referential, as in, all cretins are liars, said the cretin, or Russell's paradox, involving whether the set of all sets which are not members of themselves is also a member of itself. The integer count in one dimension depends on self-reference to proceed because 0 and 1 are logically congruent, while the other integers are logically posterior to 1 and 0. Two logic uses the second object or state as the referent. Thus, left cannot be distinguished from right except by reference to right, while right is only defined by reference to left. Left and right are neither congruent or anterior-posterior as are quantities, because they are subjective qualities. Three logic uses an unchangeable standard as a referent. Thus, state A is compared to state B by their respective difference from the unchanged standard, which is neither A nor B. Three logic is the definition of scientific methodology. A scientific experiment occurs when a state A transforms to a state B via an interaction of interest. State A is measured against, or compared to, an unchangeable standard C, which is not functionally attached to the experiment. The interaction A to B cannot influence in any meaningful way the state of C, the standard. If a standard C is affected by the interaction A to B, we cannot, in principle, have a valid experiment. Thus, an experiment like that done by Michelson and Morley fails the experimental stricture, requiring a referent that is not functionally attached to the interaction of interest, because the slab of concrete upon which the experiment rested is by definition in the ether wind. It must be considered as logically compromised. The way around this is to say that a picture of state A, or our memory of state A, might act as a proper referent. However, the slab of concrete determines the disposition of that picture or memory of state A. The concrete slab is the actual standard C. Since this experiment can't be performed in three logic, it is done in two logic and fails to produce the expected result. That is, state B has no referent other than state A, which was destroyed by the transition to state B. Special relativity finds remarkable an identity issue, which is the fact that two logic cannot produce the results of three logic. The first principle of relativity, which states that the laws of physics are the same for all inertial observers, is a result of the foregoing. However, it may require an adjustment at extremes, as other physical laws often do. I conjecture that a stream of like-charged particles at relativistic velocities may develop an experimentally discernible helical path structure and thus violate relativity's first principle. Absent the foregoing possibility, the absolute reference frame can only be detected in linear motion by reference to the cosmic microwave background radiation, whose locus of activity is at rest relative to the alpha field. The ether standard of Michelson-Morley can be detected by rotating a bucket of water as per Newton. Here the difference, AC, a bucket of water not rotating relative to the backdrop of stars, can be compared to the difference BC, a rotating bucket, because AC can be another bucket. And still other buckets can be rotated on any axis simultaneously, fixing an absolute standard with respect to rotation. My model of the photon is a composite of a plane localized wave in the alpha field and a linearly localized wave in the beta field. The alpha field decides where to deposit the energy from the beta field. As an electron moves up and down during a transition to a different energy level, it rotates first one way then the other, as shown, producing the magnetic field. The magnetic field is a twist in the alpha field. The electric field disappears as the magnetic field appears, and vice versa. All this proceeds outward from the source electron, similar to a wave on a pond but in 3 dimensions, where the amplitude decreases as 1 over r, and at angles out of the plane of greatest amplitude, our lesser amplitudes culminating in a near zero amplitude at the poles of the vibration. Coming off the poles is a linearly localized wave that is similar to beads on a string. It carries the energy of the photon and proceeds away from a source as 1 over r squared, where multiple photons are produced from multiple electrons. These are the particle and wave aspects of the photon. They are a superposition, meaning that they exist as potentials until the energy is actually deposited somewhere. A thing is what another thing perceives it to be. Thus, its state is undefined until it actually interacts with something else. The plane localized wave is polarizable. The linear wave isn't, because it cannot, in principle, define up or down or right and left. Hence it is not detected by such apparatus as would polarize the planar component. As the plane wave encounters particles in its path, it rolls dice to determine whether the linear photon, the energy component, is to be deposited there. When that is determined, the linear part, which may be 1,000,000 light-years away, if it were real, comes to that location and gives up its energy. Then both components cease to exist. Since the transmission velocity in the beta field is 10 to the 39th times light velocity, doing all this, even from across the universe, takes no more time than it takes for light to cross the diameter of a proton. It's roughly the same as the standard model, except for the linearly localized waveform. The wave function, which advances from the source particle as 1 over r, can be as wide as the speed of light can make its radius during the time of its putative existence. No matter how big it gets, it collapses instantaneously, or very close to instantaneously. I would like to say that the linear waveform from one photon followed a path laid down by another's planar waveform, because the linear form is 90 degrees off from the planar form. But experiments with single photons rule that out. In modeling something physical, we would like to stick to geometry as closely as possible, so as to make it understandable. But at some point geometry doesn't cut it. To me, any possible photon model, even remotely consistent with experiment, makes it look like the universe is trying to save bandwidth, or that it won't allow infinities in a universe of presently finite extent. Imagine 2 objects, A and B, 1 light second apart. Let both accelerate at 32 feet per second, that is, 1 g. In the first instance, let A, which is behind B, accelerate first, followed by B, which accelerates as soon as it sees A accelerate. That is, 1 second later. At constant acceleration, A will approach B at the velocity of 32 feet per second. The distance AB will shorten as a function of the uniform acceleration of A and B. In a second instance, let B accelerate first, followed by A in similar fashion. Here the distance AB will lengthen at 32 feet per second during the time of acceleration. This constitutes a relativistic effect for all extended bodies. That is, anything held together as one object and accelerated will shorten or lengthen during acceleration unavoidably as a direct consequence of the finite propagation velocity of light, and depends on whether the object is pushed from the rear or pulled from the front. This is not a Lorentz contraction. It is something else, but is most definitely a relativistic effect. This shortening or lengthening occurs only during tangential accelerations, which change the magnitude of a vector, but not its direction, while radial accelerations change only the direction of velocity, not its magnitude. This is the cause of an electron's overall orbital stability, its failure to radiate energy away from and fall into the nucleus. It is also the geometric cause of radiation when falling through a gradient to a lower available energy level, and to the absorption of energy coincident with jumping up to a higher orbit. The relativistic compression or expansion of a field or extended body by acceleration stores energy, as in an elastic medium. It constitutes potential energy. The energy thus stored is radiated away and is a function of the rate of acceleration, the duration of the acceleration, and the time required to form and radiate a photon. Thus, a slow acceleration will produce lower energy photons than a fast acceleration. In the pulling mode, an electron is attracted to a positive charge and moves in that direction. First, the front of the electron's field moves, followed by the rear. This in turn causes the beta field center to follow the curvature caused by the alpha field's distortion. This then results in a beta field distortion, which generates inertia, operating against the pull on the electron, slowing it. This slowing allows the rear of the electron field to catch up to the front, somewhat relieving the built-up potential. As the beta field center arrives at the relieved alpha field, its acceleration slows and the alpha field resumes its acceleration toward the positive charge that is attracting the electron. The process then continued must necessarily produce an oscillation of fits and starts in both the alpha and beta fields. Such oscillations are subject to systemic resonances and so radiate away energy during tangential accelerations. If the alpha field is pushed, it compresses while the beta field elongates. When inertia in the beta field slows the alpha field, its front catches up with the rear, which in this case went first. During gravitational accelerations, the beta field center goes first, dragging the electrical fields into distortions. In this case, there is no oscillation caused by the opposing interplay of charge and inertia. Rather, the alpha field follows in tandem with the beta field, producing a progressive elongation of both. As long as acceleration continues, so does the elongation. This then requires that the inertia of the particle becomes greater than the force pulling it, causing the acceleration to cease and allowing the elongated field to resume its sphericity. Then the acceleration begins again and the process is repeated, producing an oscillation and resultant photon emission. This is Bremsstrahlung Radiation. It is the inevitable progressive relativistic contraction or elongation of a field during uniform acceleration due to the finite transmission velocity of information both in the alpha and beta fields. All neutral bodies, pulled or pushed, expel lesser, negligible quantities of thermal energy when accelerated. However, radial accelerations produce no thermal energy expulsion because during radial accelerations, the front and backs of both alpha and beta fields catch up and achieve stasis while traveling in a circle or while at rest in a gravitational field. Accelerations by gravity or rotation are not the same as accelerations in a hypothetical Einstein space elevator. In all radial acceleration, there is a measurable gradient, but no space elevator has such a gradient, though one can see that the two types of acceleration are at least viscerally the same. By time reversal symmetry, an electron that emits a photon by this mechanism must also absorb a photon by a reverse mechanism, and if an electron cannot emit a given photon, it also cannot absorb a photon of that energy. If emission is discontinuous, absorption must also be discontinuous. Particle decays occur when an acceleration produces an elongation of the beta field as a prolate spheroid which has two foci. In this state, a photon can be emitted, or another particle can be emitted if the acceleration is long enough and the rate of acceleration is great enough. In this case, the two foci of an ellipsoidal field go off separately by a random walk method as each focus takes a separate path. They may do so by two methods. These are by deterministic chance or by absolute chance. Deterministic chance is the random movement of a beta field center in response to new particles coming into existence. The movement is thus causal in quantity. Random movement by absolute chance is a change in the undefined position of any particle with respect to the alpha field. Remember that the initial configuration of particles in the alpha field had unit indeterminacy by necessity. That is, no movement at all can occur if there is absolute determinacy, because every movement has a symmetric opposite. This means that the foci of any ellipsoidal field can be anywhere within boundaries fixed by Planck's constant. Their position is not completely defined. A change in position by this mechanism that results in the ellipsoidal field's foci separating as daughter particles is by the weak interaction, which is concerned with the uncertainty of position of any object. This is also the source of the quantum tunneling effect, wherein a particle can move over a gradient without being supplied with the energy to surmount that gradient. As the nuclear force is related to the gravitational interaction as beta field constituents, the weak interaction is related to the electromagnetic interaction because both are creatures of the alpha field. Decays of any sort must produce new particles by splitting two from one. Three or more particles cannot come directly from one particle because the ellipsoidal field has only two foci. To produce three particles at once would require three foci. A particle with two foci is in a temporary state of potential division due to acceleration, but it is still the same single particle. The second particle is not real until it separates from the other focus. Until then, it is only a virtual particle. Consequently, the vertices in all decay diagrams must have three lines radiating from them, one in and two out. Multiple lines in detector tracks that appear to emanate from a point are always found to have hidden short vertex stems, so that only bifurcation occurs. There is no trifurcation in existence. Consider two objects, A and B, rotating around each other. From A's point of view, B is orbiting around it, and from B's point of view, A is the one orbiting. The radius of the perceived orbits of A and B, each around the other, is here 1 unit. This is an example of two logic as applied to rotation. Both A and B take themselves as the unchanging standard to which all else is referred. If we take the mass and velocity of A or B as 1 unit, we may take the orbital angular momentum as 1 unit. Now, if we do not refer to any other standard, the orbit of B about A can be reinterpreted by A as the rotation of A on its own axis. That is, A's intrinsic angular momentum can be given the 1 unit previously given as the orbital angular momentum of B. In the case of both A and B, each sees the other as having 1 unit of orbital angular momentum, or sees itself as having 1 unit of intrinsic angular momentum. Now, if we consider these same particles in 3 logic, with an external referent, C, then the radius of their orbits around a common center is 1/2 of the previous radius, and the orbital angular momentum is now 1/2 of what it was in 2 logic, and the distance required to complete the 2 logic orbit in 3 logic is doubled. That is, to equal the former condition, the particle must make 2 3 logic orbits around the common center C. From the point of view of the referent in 3 logic, both A and B now also have 1/2 unit of intrinsic angular momentum. In 2 logic, A and B split 2 units of angular momentum. One takes a unit of orbital and the other takes 1 unit of intrinsic. In 3 logic, A and B each take 1/2 unit of intrinsic angular momentum and 1/2 unit of orbital angular momentum. Examining the probability of where each particle is, as a Gaussian-type distribution, the overlap in 2 logic is additive. That is, both indicate the location of the center where each particle is supposed to be. By definition, in 2 logic there is only 1 center, and each particle sees itself as at that center. The particles with 1 unit of angular momentum then move toward that 1 center, the probability being weighted in that direction. Conversely, in 3 logic, the center is already occupied by the external referent C, which defines 3 logic, and any overlap would be subtractive, causing the particles with 1/2 unit of angular momentum to move apart. Thus, if A and B moved toward C, the identity of 3 logic would be negated, along with objective physics, which would then necessarily be replaced with the subjective physics of 2 logic. Again, subjective means each individual using himself as the standard. Objective means every individual using an external universal standard of measure. The conservation laws of linear and angular momentum and conservation of energy may not be a priori absolutes. That is, because nature makes no choice between logically equal alternatives, is the fundamental rule of existence from which conservation laws emerge. For all natural systems, the conservation laws hold because no natural system produces a mechanism that causes logic to chase its tail in such ways as to void those laws. At least there is no known natural system violation. It may, however, be possible to artificially induce such violations. Man routinely constructs objects that are not found in nature. Some unidentified flying objects, which are surely mechanical constructs, seem to violate linear momentum conservation, as reported by observers. And, if linear momentum conservation can be bypassed, angular momentum conservation and energy conservation must of logical necessity follow. Here is a hypothetical designed to cause such a conservation failure. Let a massive ring be rotated at high radial velocities. Then the fields of the particles making up the ring will be elongated in the plane of rotation. In the case of neutrons in the ring, the two foci of the resulting ellipsoidal fields will begin to form opposite charges at those foci. If the ring is then immersed in a very strong asymmetric magnetic field, by the right-hand rule, one of the charges formed by centripetal force will move up in the field and the other down. This takes the axis of the ellipsoidal field out of the plane of rotation, thereby redirecting the inertial vector out of the plane of rotation. The resultant vectors do not cancel out, so the craft attached to the ring and asymmetric magnetic field will accelerate through space without expelling exhaust in the opposite direction. All three of the major conservation laws are thus violated. If the foregoing theory of inertia is correct, then this must be a valid physical principle. A particle does not know what our conservation laws are, nor can it know any laws of existence as a priori absolutes. It merely responds to whatever forces are immediately upon it. To those who argue that the center of mass of the universe cannot logically be moved, it probably doesn't. For every flying saucer that causes such a displacement, there is another somewhere causing an opposite displacement, such that the center of mass of the universe remains constant within the constraints of Planck's constant. Or the rest of the universe moves in the opposite direction to compensate. Bear in mind here that the transmission velocity of information in the beta fields is approximately 10 to the 39th faster than light speed, and thus the probability of movement of other matter in the opposite direction might be weighted by the supposed violation. The issue here is not settled. This is especially true when numerous observers report the same details of high acceleration with no perceivable conservative exhaust in the opposite direction. The present beta particle mass is about 10 to the negative 13th of its original unit mass. The missing portion may have gone into the maintenance of the electromagnetic interaction. That interaction has diminished only slightly by some amount proportional to the fine structure constant. Imagine the electron charge as weakening over time by becoming smaller, and also as an elastic potential growing under compression by being forced into proximity to other electrons. If the electrons were suddenly to find themselves in the universe without any positive charges, they would explode outward to fill empty space. In doing so, the potential would be lessened and the force between two electrons weakened proportionally. That is, to an extent far less than the initial unit strength. The same would be true of the protons. Gravity then compresses the negative and positive charges, while the cancellation of charges enables gravity to so act. Here is a list of the rates of change of various parameters relative to the radius of the universe associated with its overall development. These relationships must hold with only minor corrections in any ex nihilo model of existence. Pure numbers, as in the Standard Model, cannot be picked out of a hat at random and applied universally. Any ex nihilo theory of existence must posit ongoing development over time. To pick numbers randomly and apply them universally as constant through time implies that there are other universes not directly associated with this universe that cover all the other possibilities. A many-worlds hypothesis then violates the primary postulate, which requires that for a thing to exist relative to another, it must interact with that thing. Hence, another universe that we cannot in principle detect is the definition of non-existence. The Anthropic Principle constitutes an application of this false, many worlds concept. Here it is supposed that we occupy a special universe wherein all the physical constants are just right to facilitate our existence, and that if they were only slightly different, we could not exist. The specialness of our existence is eliminated by supposing an infinite plenum of other universes which do not contain living beings. However, if it is also supposed that these other universes develop over time, demonstrating increasing entropy, then they too must also develop intelligent beings of a different sort, all of whom wonder at the coincidences of their peculiar status. These life-containing entropic universes must be infinite in number also, so that all specialness is thereby removed, which was the initial cause for the speculative anthropic principle. The universe, at its most fundamental, is reasonably uncomplicated. It becomes complicated rapidly as one proceeds down any deductive path. Hence, are we able to understand it at all?